Hi everyone. This is my second take here. I already did this and I went over the 10-minute mark and I just decided to start over again. This setup, or this test number 9, is to show that without a shadow of a doubt the energy that's going to the two coils are of no cost from the input energy. To prove that, I've eliminated the use of the variac and the capacitor that I was charging and using that meter over there to measure what energy was being consumed. So I've removed all that and I created my own energy using 5 9-volt batteries in series. Alright, and these are really cheap batteries. I get 2 for $1 at the dollar store, 9-volt batteries. Okay, and at this time now the batteries are about at 48 volts, all of them in series right now. Now I started the video, they were at around 50 volts, but it's consumed and they go down quite a bit because you have to keep in mind when they're in series the capacity is just like one single battery. Alright. So I'm using this to make sure that, you know, there's no doubt that what I'm been measuring is, you know, really happening. And it is. That is the good news. So Merry Christmas to everyone. I will start the circuit and you will see that the amount of energy that's consumed by the circuit, just pulsing alone without the coils, all right, is not going to change when I load the coils on. Even with this, you know, cheap battery bank here, it's not going to change. We have the same setup here, the 2 capacitors with load. All right, that one's a 5 ohm load, and this one here is a, sorry, maybe too much light there. That one there is the 10 ohm load. All right. And so we have the 2 coils. The 10 ohm load coil is here at this meter, which is set on the 20 volt DC scale. This meter here is on the 200 volt scale, monitoring the battery pack. And this is set on the 20 volt scale as well. This meter here is going to be displaying what is actually at the 10 ohm load capacitor, and this is what is at the 5 ohm load capacitor. Alright, so I'll turn on the circuit. All the wires are very clear here, nothing's hidden. This is coming from my signal generator, which is feeding the logic side the frequency that the logic needs to switch to send to the transistors. And this wire here is going to this battery here, which is supplying the 12 volts needed to operate this logic side. Now I've already tested to make sure that the logic side is not bleeding into the switching side, and I can confirm to you that it isn't. Okay, that is not happening, and this is consuming somewhere around 40 milliamps. And I'm keeping it separate. I don't want to add it in the equation because I know this effect can actually get amplified, and that's nothing compared to it. What I'm really interested in showing here is what this circuit is capable of doing and what happens when these coils are at resonance and all this kind of thing. So these 2 coils are identically matched, and they're tuned by this little about 250 picofarad capacitor here that's in series with this flip-flop, DC flip-flop circuit. Alright, so as you see the voltage is going up slightly because the batteries are at rest right now, and it'll soon drop as soon as I start the circuit. Now I have a little problem here. I've got a little switch that I just stuck into my project board, and it's kind of flimsy, and I actually had it pull out. Anyways, that's the switch that I'll turn on to load the coils, and you'll see that once I turn on that switch, absolutely no voltage drop here at this meter, which is the incredible part, because you'll see that the capacitors with the loads will each display a voltage. So as far as I'm concerned, what is going to be happening at these 2 meters here okay, is definitely the extra energy, because we cannot, trying to arrange the light here so it doesn't flash in there, we cannot have this extra energy if we're not, you know, draining the source that the energy is coming from. And that's what I'll demonstrate in this video. All right, so I'll start the battery. I'll start the logic circuit, and as soon as I start that, you'll see the battery, okay, voltage is going to drop. All right, so that's dropping to where the draw of this pulse circuit is using. We don't know quite why it's consuming this energy, and it's somewhere around 24 milliamps that it's consuming. And actually I know that these two ICs get hot, and they shouldn't, and I think they're being dissipated in these two ICs somehow. But we're going to study that and find out exactly what's going on there. But as you see, that's what we have. We've got 46 volts at, you know, or 45.9 right now. It just keeps going down. So that's the normal rate. It'll keep going down and down. Keep in mind, these are cheap zinc batteries, 50 cents each. It's going to go down fast. All right. But the incredible part is, as soon as I load the coils, notice, actually, the voltage went up. Notice that there is no drop in this, and yet we've got 1.85 volts there and 1.20 volts there. All right, and that's being maintained. That's a continuous load. There is no way that we can continue that continuous load and not, okay, have a voltage drop here. So obviously my other setup with the other meter was measuring correctly, because when we load the coils, we're getting energy stored in the capacitor and with the loaded resistor, and that's not possible to do with this flimsy little battery bank here without seeing a voltage drop. Now, I do agree the voltage is dropping, but it's not at the cost of this here. It's at the cost of whatever the energy is being dissipated in this circuit here. All right, so I'm quite positive, I'm now convinced, I don't need any more convincing, that this circuit is functioning as I have claimed, and this information is for the world, and it's going to be shared, and hopefully this will help those in need. Thank you very much for watching, and I will post in the video the math to give out the energy output on this. All right, I'll just flip the switch off to show you again. All right, did you see that? The voltage is actually dropping. Okay, the voltage at the battery bank is dropping when I'm actually disengaging the two. That's because I can actually tune it to the frequency that I can actually send back energy the other way. All right, and I've got it at a point where obviously I'm not drawing anything, okay, from that bank when I flip it. All right, and I can go the other way. I can have more energy coming out here, and then you will see a drop here. Okay, I just arranged it at a point where it's equalized. It's not drawing anything. Again, I'll flip it on for you. Look at the voltage. On. See? Voltage goes back up. All right, so it's doing this at no cost. Okay, Merry Christmas everyone, and Happy New Year, and I believe 2009 is going to be a great year. Anybody that wants to participate in this, look at the description box and you will have the links to the forum topics. Thank you.